Hello everyone, this is Ziho, and I will be responsible for going through the solution for this worksheet. So let's start with problem 1. So the problem 1 says that there's 5,000 students and 200 of them are math major. So that means 4,800 of them are non-math majors. And I interviewed 50 students, and we let X to be the number of math major that I interview. So if we look at the problem and then we look at the first problem, we need to identify the name of the distribution of X. So this question is like, X can be what? Maybe we can first start with the range of X instead. So X is a number of math majors you interview. So I can either have very unlikely 0 math majors out of the 50. I can also have 1 or 2 or up to 50. So that's my range. And also look at the question where choosing some of the students in choosing the 50 students, and these 50 students can be math major or non-major or non-math major. So this is kind of choosing good or bad thing. Although math major is definitely the good part. So if you do remember from the lecture, hypergeometric distribution is a distribution that measures choosing the good part and the bad part, and the formula for that is this. So n here is basically the big population. So in this case it's 5,000, and from the good part there are 200 students, and we want to choose k students, and the bad part, the non-math majors, we want to choose n minus k. So the probability distribution of that is 200 choose k times 4800 choose n minus k, and given the total, we choose 50 students out of 5,000 students, and then we are asked to calculate when the random variable equals 4, and that is easy. We can just simply plug in the formula to get the final answer that I have shown here. So then we look at problem 2. And for problem 2, the problem says, assume that the number of people who arrived in an emergency room at a hospital each night is a Poisson random variable with a parameter lambda equal to 20, and let X be the number of people who arrive at the emergency at that night. So the question has already tell us that it's a Poisson distribution. So we already get the answer of problem 1. And we look back at the random variable. X is defined to be the number of people who arrived at the emergency room that night. So remember, for Poisson distribution, the range of that can be 0, 1, or 2 up to infinity. And it also makes sense in this context because there can be 0 people, 1 people, 2 people, up to infinity people showing up. And also for probability distribution, remember Poisson distribution's formula is lambda to the kth times e to the negative lambda over k factorial. So that's the probability max function of random variable equal to k. But what do we know now? We are given that the lambda is equal to 20. So we can just plug in 20 for the original equation. And that is our probability mass function for this context. And the last problem is to calculate the probability when random variable of x equal to 4. Again, we just like plug in k equal to 4 in this context. And if you use a calculator, in fact, we will get a result of 1 point something to the 10 to the -5.